Hello, this is our video solution for problem 5 from Superquiz 1. In this problem, we are given a subset of the domain, right, that is of the xy plane really, and asked to find out at which points in this rectangular section of the xy plane the function root 2x minus y over cosine of x is continuous. Now, in a previous video, which we'll link to in the description, we talked about what the domain of this function was. So the domain, and we'll do it in, say, set builder notation here, was all points x comma y, where the y value had to be less than or equal to 2 pi, and the x was not equal to pi over 2 plus some integer multiple of pi. So k here was an integer. Okay, that's first observation. Second observation is we have two continuous functions, at least where they're defined, right? So I have a function which is continuous everywhere in its domain, divided by a function which is continuous everywhere in its domain. And there's a rule that says that f over g is continuous when f and g are continuous. And g does not equal 0. So all we need to figure out is essentially where do we get 0 in the denominator. Of course, we've already figured that out. That's where this x value is pi over 2 plus k pi. And where this top function is actually defined, because that's where it's going to be continuous, because it's a square root function. And again, we know where it's going to be defined. It's going to be defined for all values of y less than or equal to 2 pi. Okay, well, 2 pi is about, I don't know, 6 or something. So 6 is way up here. So this y restriction is not a problem for us, right? So the only restriction we really have is when is the x pi over 2 plus some integer multiple of pi? Now, pi over 2, that's about 1.5. So let's see what happens if I start adding integer multiples, right? So if I do pi over 2 plus 1 times pi, well, that's going to be about 4.5, which is well outside this range. If I do pi over 2 minus pi, well, let's see, that's about 1.5 minus 3. That'd be about negative 1.5. And that actually is going to lie inside of here. What if I do pi over 2 minus 2 pi? Well, that would be 1.5 minus about 6, so that's going to be about negative 4.5, which is, again, too far to the left. So the only points where we have an issue are going to be at pi over 2 and at pi over 2 minus pi. We can't allow the x value to be either of those. So pi over 2, again, it's actually a little more than 1.5, so there's going to be pi over 2. And then pi over 2 minus pi, that's actually the same thing as negative pi over 2. That'll be about here. So there's our negative pi over 2. And we know we cannot allow our x coordinate to be pi over 2 or negative pi over 2. So f is continuous on, so let's write the set in set builder notation, all x comma y, such that, well, okay, first thing, we have this rectangle here which automatically tells us that the x values go between negative 3 and 3. So we could write that in. So negative 3 less than or equal to x less than or equal to 3. Also, the y values have to lie between negative 2 and 2. So negative 2, the y values lie between negative 2 and 2. And then we also need this extra condition, x does not equal plus or minus pi over 2. And there we go. That is all the points of continuity.